When the Geological Society of London was founded in 1807, CO2 was at a level of 280 parts per million in the atmosphere. 280 molecules in a million molecules of air. 280 was a magic number. Just enough to help melt back the grand ice sheets that covered Scotland and North America at the end of the last ice age and allow all of human society as we know it to thrive. 280 was the level around which the pyramids and the Great Wall of China were built, but it was also the level at which a Scotsman, James Watt, invented his steam engine, a device that turns the most carbon-rich rocks on our planet directly into atmospheric CO2. You couldn't design a better way to elevate CO2 in the atmosphere. By the time I was born in 1985, CO2 had risen to a level of 345 ppm. 18 years later, in 2003, I started university and CO2 was 375 ppm, and 18 years again, and here we are today in 2021. CO2 is 414 ppm, and I have a 3-year-old and a 6-month-old baby. What will CO2 be when they are as old as I am, or when they have kids or grandkids of their own? This question is the central reason that I'm speaking to you today about the past and future of CO2 change and about the COP26 theme of youth and public empowerment. What world do we leave behind for the kids of today and tomorrow? My name's James Rae and I'm a geochemist and a climate scientist at the University of St Andrews in the Department or School of Earth and Environmental Sciences. My research uses chemical fingerprints in things like fossil shells and ice cores to look at the history of climate change, with a particular focus on how CO2 has changed in the past to better understand how climate will change in the future. Now, we've known about the incredible heat-trapping properties of CO2 for an awfully long time. In fact, the first experiment that showed how CO2 traps heat was way back in 1856 by an amateur American scientist called Eunice Newton-Foote, who showed both how CO2 traps heat, but also made the first connection between past CO2 levels and intervals of different climates in the geological record. That link was further discussed in this incredible paper by Svante Arrhenius in 1896, where he makes the first detailed calculations of the impact of CO2 on Earth's climate and goes on in this wonderful section 5, Geological Consequences, to hypothesize about the impact of CO2 through Earth's history. And it starts with this wonderful phrase, "I should certainly not have undertaken these tedious calculations if an extraordinary interest had not been connected with them." And that extraordinary interest, of course, is the geological record, it's Earth's history, and he hypothesizes that lower CO2 would have helped drive the ice ages, that higher CO2 in a distant past could have driven warm climates in the age of the dinosaurs, and indeed he points out that burning of fossil fuels will warm our planet into the future. Now, it took over 100 years, but we have now been able to test these hypotheses put forward by Arrhenius, and one of the most striking demonstrations of that is using these beautiful tubes of ice from Antarctica. Between the snowflakes that made up this ice are trapped bubbles of air. This is our fossil record of the atmosphere, and by cracking these bubbles open, we can measure the CO2 content of that ancient atmosphere. So when we do that, this is the picture that emerges. We're looking here at 800,000 years of our atmosphere's history, and we see this regular repeating pattern with low CO2 of around 180 ppm during ice ages, rising to levels of about 280 ppm at the end of an ice age. So, for reference, this is the peak of the last ice age, about 20,000 years ago. This is a time with a kilometre of ice on top of where I'm currently sitting here in St Andrews, and globally with sea level 120 metres lower. At the end of that last ice age, this CO2 right here helps melt back those massive ice sheets. CO2 rises, sea level rises by 120 metres, and this wee window here of very stable CO2 and climate contains the entire history of agriculture and of settled human society as we know it. So this is an interval called the Holocene, about 10,000 years, and this now is what we've done in the last 100 years. CO2 today is at 414 ppm. So this is completely unlike anything seen for the last 800,000 years of Earth's history. So if we want to know geologically what a world with 414 ppm of CO2 looks like, we need to go deeper into the geological record. To do that, we use these tubes of mud from the deep sea floor. They contain these beautiful microfossil shells, and because these shells grow in seawater, taking in the chemical fingerprints of seawater as they grow, we can look at various of the elements in these to reconstruct conditions in the ocean and the atmosphere over geological time. And this is really a lot of the work of myself and my research group. We are boron morons, both boring and moronic, but usefully using boron to reconstruct the long history of ocean pH and atmospheric CO2. So when we do that, this is the picture that emerges. For context here, you'll note the x-axis is broken up. So there is kind of recent human history. Here's our 2021 levels, way above anything seen in the ice core records. And now here in this left part of the graph, we have tens of millions of years here. And so we're going to step back through millions of years to look at how CO2 has changed. And we see here, right, if we go back to this is the demise of the dinosaurs here at the KPG boundary, and then this is the history of the last 60 million years or so. So you can see that CO2 has changed before, but those changes are associated with worlds completely unfamiliar to our species. For instance, in the Eocene, where we have CO2 levels of 1,000 ppm or more, we have alligators roaming the Arctic. And there's a whole bunch of different ways that we can tell how climate changed in the past, but finding the fossil skeleton of a cold-blooded creature is a pretty reliable indicator that winters were above freezing. And to look for our 2021 levels, we find those here in the Pliocene 3 million years ago, and even at this level of CO2, the surface of much of the world as we know it is transformed. There are forests of beech trees growing in parts of Antarctica, and there's no ice or very little ice on Greenland. Globally, these Pliocene sea levels are 20 meters higher. And depending on our future energy choices, we have the potential to send CO2 back towards these Eocene levels. But even the Pliocene is too much, right? 20 meters of sea level would transform the face of our planet. I'm going to demonstrate that on this map of central Scotland. Here is the COP26 conference centre, 9 meters above sea level. Most of these blue colours, these dark blue colours, would be swamped with that Pliocene type sea level change. Now, thankfully, it takes big ice sheets some time to melt, though just how long is a really open scientific question, and one that's being worked on pretty hard. The latest IPCC report shows that by 2300, we can't rule out sea level rise greater than 15 meters if we allow CO2 emissions to continue unabated. And even at more modest levels of CO2 rise, we may have already locked in a bunch of rising sea level. But actually, even in the more immediate term, this sea level rise is a big deal. By 2050, there's very little uncertainty really on what sea level is going to do. We have 35 centimetres or so already locked in. And that 35 centimetres is going to transform a bunch of the places where people live. And this was shown really dramatically in a paper from a couple of years ago that updated these estimates of what sea level would do to our lived environment based not on new projections of sea level, but just on better information on the land surface elevation. And so here, the results of that study showing this enormous flooding in southern Vietnam and northern Egypt. And of course, sea level is just one of the many impacts of climate change on our lived environment. These range from melting permafrost in the Arctic to stronger tropical storms in low latitudes. The amount of extra heat energy that we have trapped with our carbon emissions is the equivalent to 600,000 Hiroshima atomic bombs going off every single day. So just think about that amount of heat energy, 600,000 of those bombs going off every single day. That is the same amount of heat energy that our CO2 is trapping at our planet's surface. And that just has huge potential to do things to our climate system. So it makes tropical storms more powerful. It leads, of course, to rising temperatures and changes in precipitation, which drive crop failure. The rising temperatures in tropical oceans drive coral bleaching events, which are devastating to the communities that depend on these environments for their livelihoods. And one of the most noticeable and striking impacts of that extra heat energy and that rising temperature is at what it does to our water cycle. And this is something, again, we've known for well over 100 years, since those Victorian steam engineers worked out something called the Clausius-Clapeyron equation, which basically just says that for every degree C that you warm the atmosphere, it can hold about 7% more water vapour. Now, the effect of that is twofold. In the hot, dry places where water tends to evaporate, the atmosphere is now hungrier for water vapour. It leads to more evaporation and makes those places hotter and drier. And that is, of course, the perfect recipe for making forest fires intenser and more devastating. We've seen the impacts of that already in Australia and California. It also means that there is 7% more water vapour that has the potential to rain out in rainstorms. Each of those big rain events can now be 7% wetter, even with 1 degree C of warming, and that leads to more flooding in wet places. And the impacts of this changing climate will just continue to ramp up and get more extreme with every extra joule of heat energy trapped and every fraction a degree of extra warming. Now, we know why this climate change is happening, and this is really the first step in solving this problem, right? We know exactly why it's happening, which in a way is good news, right? This is not some unknown catastrophe that we have no clue about how to solve. Climate change is happening because of carbon emissions, and you can see that in simulations of Earth's temperature over the last 170 years. With natural factors only, they rumble along. Climate fluctuates a little bit, but basically around zero. Whereas when we add in carbon emissions, our models simulate very well these days the observed global warming. And so, predominantly, it is those carbon emissions come from the burning of fossil fuels. This has powered human society with the release of energy from these covalent bonds in big organic molecules. But the side product, the waste product of that, is carbon dioxide, and we have just freely dumped that waste into the atmosphere like it's an open sewer. And we are now doing this at just an extraordinary level, 100 million tonnes of carbon emissions into the atmosphere every single day. It's a kind of staggering number to try and get your head around. 100 tonnes, for reference, is about the weight of a blue whale or a kind of moderately sized aircraft. So just imagine 1 million of those entering the atmosphere every day. CO2, we can't see it, but that doesn't mean it isn't real, and it has real mass, and it has real and very effective ability to trap heat. So, drilling down in a bit more detail, where are those? Why are we creating those greenhouse gas emissions? Well, this figure shows the breakdown of greenhouse gas sources. About a quarter comes from the production of electricity. There's about 14% from transport. There's heating and cooling of buildings, heavy industry. There's the process of just extracting fossil fuels, flaring, methane leaks, and then there's also a quarter or so from changes in land use and agriculture, so deforestation and burps of CO2 from cows and paddy fields. So if we want to fix climate change, and based on those impacts and the growing impacts on young people, we really have to fix climate change. The way to do it is essentially we need to do two things. It boils down to two main steps. The first thing is we need to clean up electricity, and that's something that we actually have some. We have the technologies to do that already. And then we need to replace fossil fuels and the energy they provide with clean electric energy. So step 2 is to electrify everything with things like heat pumps in homes. A kind of just an awesome technology, right? Move the joules of heat that are outside in the world inside to your house with just the use of a wee pump and a heat exchanger. We need to power our cars with electricity too. And this, again, this is pretty exciting. We got an electric car last summer. It's like a spaceship and it costs $5 to fill up. And we also need to find alternatives for fossil fuel power in heavy industry, and to think about ways that we can capture CO2 from these remaining sources of emissions, for instance, in cement and steel production. Finally, and again, critically, we need to protect and enhance sinks of CO2 from the atmosphere. There's a lot of work to do in here, but there's also a lot of exciting opportunities, and that's particularly true for earth and environmental scientists, who are going to be absolutely key in finding the 21st century materials that we need for this green electric future, and also in figuring out ways of removing CO2 from the atmosphere. So again, why do we need to do this? Well, to me, it's something I care about as a climate scientist, but actually more so as a parent. This is the world that our kids are going to grow up in. This kind of, these 21st century climate scenarios, the state of CO2 and climate by the year 2100. This is not just some kind of meaningless statistic. This is the world that they are inheriting, the world that they are growing up in. And the impacts of climate change will be more and more apparent, not just on their kind of physical environment, but also economically too, with any estimate of the costs of climate change always way outstripping the costs of action. So this ties us into this COP theme of youth and public empowerment and engagement, because young people are acutely aware of this intergenerational climate injustice. They have done the least to cause this problem, but they will feel its impacts most acutely. And really inspiringly and amazingly, they are leading the charge in fixing this problem. And I want to give a couple of examples of that. The first is centered on this incredible youth movement, the school climate strikes, started by Greta Thunberg just a few years ago, when she started skipping school to protest for more climate action. And again, on the theme of youth and public engagement, this from her speech at COP24 in Poland: "We have come here to let you know that change is coming. The real power belongs to the people." And this this might sound just like a kind of rhetorical call to arms, but this movement is really making a difference and getting noticed. It is global in its reach, going from South Africa to St Andrews here. And it is being noticed as high up and as influentially as the head of OPEC, the cartel of major oil and gas producing companies, who in 2019 said that these school climate strikes were the greatest threat to the oil industry, noting that there was a growing mass mobilization of world opinion against oil, which was beginning to dictate policies, corporate decisions, including investment in the industry. A second example of the power of young people comes from the US, where the Sunrise Movement in 2018 staged a sit-in at House Speaker Nancy Pelosi's office to demand more action on climate change. The momentum started by these young people kind of snowballed with the proposal of a Green New Deal and with a kind of complete transformation of the Democratic race for presidential candidates, with Jay Inslee running for Democratic nominee on a ticket of climate action. And again, he notes that this is the most important work we can do for our 3 grandchildren and for grandchildren across the country. What he starts, spurred on by these young people and his concern for future generations, snowballs into the different candidates on the Democratic ticket trying to kind of outdo each other on climate action. And when Biden eventually becomes the nominee, he listens to young people who are saying that he's not bold enough on climate action. He puts together a task force that includes the head of the Sunrise Movement, Varshini Prakash. And as a result of their input into that process, he moves forward his clean electricity targets by 15 years. And he has now, as president, hugely increased the ambition of the US in terms of climate action, with a $555 billion climate plan currently on the table. For reference, Obama's climate plan in 2009 was $90 billion. So this Biden's dwarfs this, and yet even that $90 billion climate plan was enough to signal to the energy industry the direction of future travel. And we can see this here in this enormous decline in the US in coal consumption and the rapid growth of renewables. So no one is too small to make a difference, but we can't leave fixing climate change to young people alone. And so I want to finish with a call of action really to all of us to act on climate change. And that, can seem a really daunting and kind of big thing to try and figure out how to do. But the most important thing to do, and this is really the easiest, is to make some noise about it, to talk about it. So if you are concerned about the impact of climate change, and if you are interested in climate solutions, and as earth and environmental scientists, I think we really have to be both of these things, please make this part of your conversation. And the need for this is really kind of starkly demonstrated when we look at the national conversation. It seems right at the moment, at the time of COP, like there is a lot of talk about climate change. But looking at 2020 and looking at broadcasts on UK TV, cake, that's right, cake, chocolate cakes, vanilla sponges, whatever, delicious, but they are talked about 10 times more often. They are mentioned 10 times more often than climate change, which, it is frankly just astonishing. We need to make climate change, this biggest problem that humanity has ever faced, we need to make it a big part of our national conversation, because that is the way that we then push the levers of power. And right, this is not about changing what straws you use. This is about action across our society to change structurally the ways that we get our energy to be cleaner and emit less CO2. So think about how you can amplify your voice, find a group that aligns with your concerns. These are springing up all over the country. And then think about who else can you influence. What energy does your workplace use to heat its buildings? And what is your bank or your pension doing with your money? Are you inadvertently funding atmospheric pollution? Finally, and most importantly, let your politicians know that you care about this. Let them know that their re-election, their job, depends on climate action. And that looks like ending the enormous tax breaks and subsidies that fossil fuels continue to get, supporting renewable energy, and giving funds for a just transition to this clean electric future. So helping people along with funding for electric vehicles, heat pumps, and insulation in homes. This transition has to be just. It has to be something that brings along all of society. And know that we can really make a difference. We see this, for instance, in UK emissions levels. They've fallen by more than 40% since 1990, but we need these emissions cuts to go further and faster. So I'll finish by looking again at this long history of CO2 change. We are already at these levels of CO2 that we haven't seen since the Pliocene. And this is just a completely different world. We have built our houses in a planetary climate system that just simply doesn't exist anymore. And the impacts of that will be more and more acutely felt with every increment of rising CO2 and rising temperature, and with every passing year, which is why we owe it to our kids to send them into a safer, greener, cleaner, and ultimately better and more exciting future. Thanks very much.